Hello, we are going to do the, one second, oh my gosh, it just got all wet. We're going to do the solar water desalination video. So we're going to first set it all up. So let's make this. So I have the larger container, and I did fill it up with water, but we'll fill it up with water again. So what we're going to do is fill this up with 1 cup of water. Okay, 1 cup of water. Next thing we need to do is we need to add the salt. So let's see here. Where do we have salt? We have salt on here. Okay, so we need a teaspoon. Yeah, half teaspoon. Oh my, okay, that's a little bit too much. Okay, pour that in. And it says we need to stir that up. So we get a spoon and stir that up. Going very well so far. Looks like the salt is mixing in with the water. You can maybe call that chemical bonding, right? Because some of those chemicals are breaking apart maybe into different, together. And yeah, we'll see what happens. I'm putting my energy into this by moving around the particles. So that's kind of like activation energy, right? Alright, so looks like the salt is pretty much mixed in there. Next thing up is we place the smaller container inside the larger container. So my smaller container is right here. We're going to add that in here. Okay, awesome. Then the next thing we need to do is cover the large container with plastic wrap. So we will do that. Hopefully we have plastic wrap. Give me a second. Yeah, we have plastic wrap. So we're gonna wrap this. Don't need a lot of plastic wrap, but we do need enough. Okay. So how does it say to cover it? The wrap should not be touching the smaller container, okay? Alright, we will do that. Okay, the wrap is not touching the small container. Okay. Alright, what's next? Add the weights to the center of the container. Okay, so we're gonna go ahead and grab some weights from my yard. So let's go do that. So, okay. We're just gonna grab some rocks. Actually, we're just gonna go over here. Okay. We're gonna grab some rocks and then, yeah, it'll be good. Okay, here's a rock. And here's another rock. Let's grab one more rock. Okay, so we got the rocks. We'll go back inside. This is a fun experiment. Okay. So what I'm thinking now is I should take it all out. What does it say next to do? Yeah, so we're gonna go ahead and take it all out now. So I'm gonna set my rocks on the iPad. Actually, I'm not gonna do that. That was really silly of me. Okay, now we have brought it out. It's now sitting right there in the sun. And so what we're gonna go ahead and do is add these rocks that I found right here. We're gonna put them on so that it drips. Ooh, I should have made it a little bit more loose. Maybe it's good that it's not super loose. Is that gonna work? Maybe we should loosen it up a little bit. No, I'm not set on this side. Okay. Give us 1 second. We're gonna figure this out. Okay, so that should do it. Yeah, that should be good. Yeah, all right. So there it is. You can see that the rocks are gonna point it into that one, and it looks like it's going to be strong enough to stay up. So yeah, I'm just going to make sure it's nice on each of these sides. And yeah, so it looks like it's ready to go. We'll let it out for about 2 hours. Well, we're gonna let it keep going until the end of the day, since I have an activity to go to, and then we'll diagnose what has happened. Okay, so we just took it out. It's been outside for since like 2 o'clock, so 7.5 hours or so. And if you look here, there's barely any water there. I would say, honestly, like that's it. So not a lot came out of it. Let's see. I'm gonna measure it really quick. So I got these super small ones. Oh my gosh, that's not gonna work. We're gonna go ahead and try out these. Alright, so okay, so it's about a tenth of a teaspoon. So not a lot came out of it, sadly. And out of the cup that was put there. So next question, how effective was the solar still in distilling the salt water? So it was not that effective. If you think about it, 1/10 of a tablespoon is a small amount of all of this water. There's still a bunch of water in there. Though on this foil itself, there was a lot of water. So I'll go over that later. So it wasn't effective. So taste the water now. So I'm gonna taste the water and tell you what the difference, what the difference is. Okay, it's pretty good. So I just tasted the what do you call it? The desalinated water, and it tastes kind of like tap water. It tastes normal. Then I'm gonna taste the salt water. Yep, so salt water just tastes like salt. The desalinated water tastes different than tap water. I guess it tastes different than tap water because it's changing its its chemical molecular shape because of that salt mixing in with it. It might have like tampered a little bit with its molecular shape, affecting the taste to differ with tap water. In terms of the solar still, it was the thermal radiation due to the heat coming off of the sun. The heat difference caused the water to go through thermal radiation, which then created a conduction of the water, or a evaporation of the water, to where it evaporated and it couldn't go anywhere because it was stuck in that space. So it had to go to the top part, and then when it was strong enough, it would then pour into the smaller container. And so we conserved all the energy by getting the energy from the sun, putting it in, and having it have a solar reaction or thermal reaction to the water, which then would evaporate and condensate into the smaller one. And so the energy was conserved throughout that process. But also there might have been a loss of some sources of energy due to the fact that it was a heating of stuff in a lower temperature, because that is a chemical reaction that causes, I think, or it might be the other way around, but it might cause a loss of energy, kind of a leftover. So the size and shape of the outer container affects its efficiency, I believe, because it is so wide. So because it is so wide, as you can see right here, the wideness causes it to take a while to, I think as a whole, to heat up, because there's such a large mass, or such a large density, or I shouldn't say density, it's such a large length. And then the depth of water in the evaporating container also affected it too, because it was it was pretty deep still. I think maybe if I did a more shallow, maybe larger, even though it is larger, it would be more shallow. That would have helped. So maybe the size was good, but the depth was not good. So to improve this, I would honestly, one thing that was wrong is it wasn't really the water that evaporated and then condensed. It's a lot of it was still on the foil. It didn't fall into the cup. So I think I needed to put more pressure in the middle with those rocks. Maybe get more rocks or like make it less tight so that it would have fallen in. Other than that, also I put it in a way where it wasn't on the ground. I think if I put it at a better spot on the ground, I moved it to a mailbox. So I think if I put it in a better spot, it would have heated up more quickly. So that would have been an improvement. So thank you guys for listening, and have a great day or a great night.